All right, we have a Forest Service helicopter, and it needs to determine the width of a deep canyon, which is the length from E to D. While hovering, they measure the angle gamma equals 48 degrees, which is up here, at position B. And then the helicopter goes down 400 feet, and at point A, it measures an angle over the canyon of alpha, and it measures the angle from the downward elevation towards the line of where they're working as beta 53 degrees. Now we're supposed to find the width of the canyon, which is right here, based on just a little bit of information. So when I first looked at this, it was pretty stumping, but then what I decided to do is just draw out each triangle, label what I know and what I don't know, and then see what I can do with that. So here we go. Let's see, if I label the big triangle, this one's going to be BCD. I know that this angle here is gamma, which is 48 degrees. And I know there's this little short length right here that's 400 feet. This is an unknown length right here. I don't know anything about it. I know I need this whole length BC if I want to use the trig functions. So I'm just going to call it x. So then this whole length becomes 400 plus x. It may or may not help, but let's just see what happens. Then I'm going to draw the shorter triangle, or shorter height-wise, it's still long. And this is going to be C, D. And we have this angle here is beta. That's 53 degrees. And I have this length here is this short length. I called it x. So this is x. And then I have the smallest triangle, this one here. Goes up the same height, but doesn't go out quite as far. So it's going to be A, C, E. And this bit right here is going to be beta minus alpha. So beta minus alpha gives me this length. So 53 degrees minus 13 degrees, right, because alpha is 13. 53 minus 13 is 40 degrees. So this angle here is 40 degrees. This height is the same height here. So that's x. Now what I'm going to do with these three triangles is just do some trig stuff on it and see what happens. I mean, what I really want is this length from here to here, ED. So I know if I can find the length CD and subtract off the length CE, I get the length ED, which is what I want. Okay? So my goal is to find CD and CE. So let's start with this triangle here. All I have is an angle and an adjacent side, and I can describe the opposite side with the length CD, which is what I want to do. So what is that? Adjacent and opposite, so that's tangent. Tangent of 48 degrees equals opposite length, so that's CD, over adjacent length, 400 plus x. Now from there I can actually solve for CD fairly quickly, which I'm going to do. 400 plus x, tangent of 48 degrees. Okay, that's from triangle number 1. So let's just call this triangle 1. This is from triangle 1. Now let's talk about triangle 2. I still have an angle, and I have a length of side opposite, which is CD, and a vertical side x. So I can say the tangent of 53 is equal to the opposite length over adjacent. Now that's kind of nice. Look at that. I'm just going to leave it like that for now. I mean, I may or may not solve for CD. I'm not real sure. I'm just working through the problem just like you would work through the problem. Actually, I am sure I do know how to do this, but I'm kind of trying to help you think through it. But then in this last triangle 3, I'm going to do the same thing. I know that tangent of 40 degrees is equal to CE over x. Now, x seems like it's something I want to find. If I can find x, I should be able to find CD and CE pretty quickly. So how can I find x based on this? Well, I know that CD is equal to this here and has an x in it. And over here, CD is equal to x times tangent of 53 degrees. So I know that if that's length CD and that's length CD, then they're equal. So let's write this out. 400 plus x times tangent of 48 degrees is equal to x tangent 53 degrees. And again, if I solve for x, I can find CE and CD and then find ED really easy. All right, now how do I solve for x here? I see I have two x's. Don't be too excited. Don't divide by a variable. And tangent of 48 degrees and tangent 53 degrees are just numbers, so treat them that way. So the first thing I'm going to do is distribute the tangent of 48 degrees. So 400 tangent of 48 degrees plus x tangent 48 degrees equals x tangent 53 degrees. Take your time in doing this. There's no rush. There's no hurry. Now, the two terms with the x's in it, I want to put on one side, and everything without the x's on the other side. So I have 400 tangent of 48 degrees is equal to x tangent 53 degrees minus x tangent 48 degrees. Now, the whole point of doing that is now I have an x in both of these terms, and I can factor it out. So x is times tangent 53 degrees minus the tangent of 48 degrees, factoring it out. And then over here, that's 400 tangent of 48 degrees. Now, then lastly, to isolate for x, I want to divide by this number here. So x is equal to 400 tangent of 48 degrees divided by tangent of 53 degrees minus tangent of 48 degrees. Well, that is just a number. Look, there's no variables in there. So now let's stick it into the calculator and again an approximate value for what x is. All right, where's my little trusty machine? And again, we're in degrees, so make sure you're in degree mode. So this is going to be 400. Well, let's put parentheses around everything just in case. 400 times tangent of 48 degrees parenthesis divided by parenthesis tangent of 53 degrees minus tangent of 48 degrees. Make sure that's got our parentheses off. So I have a parenthesis around the top, I have big parentheses around the bottom, and parentheses to close out my input. That should give me a number. 2052.5818. So this is going to be 2052.5818. 0.5818. And this is going to be feet. So they're pretty high in the air. That's a helicopter. 2,400 feet. Okay. So if I keep going, sorry, I was just checking something. If I keep going here, I have my x value right here. And I know that if I plug this in here, I can get the value for CD. And if I plug it in here, I can get the value for CE, so I'm almost done. So I know that from above, CD is equal to x times tangent of 53 degrees. And I know that CE, well, let's finish this up here. I multiply both sides by x here, and I have CE equals x tangent of 40 degrees. So then down here, CE is equal to x times tangent of 48 degrees. So let's see what those values are. So I'm going to take the answer to my, well, let's just write down this. 2052.5818 times tangent of 53 degrees that gives me 2723.86. Let me just write this down. 2723.8680. And then CE is going to be the same thing. The only difference is instead of 53 degrees, it's going to be 48 degrees. So 2279.6230. 2279.6230. Okay. Now I said earlier that the length CD minus CE gives me the length of my canyon right here. So CD minus CE gives me the value that I want. So that means, luckily, this is bigger than this. That's a good sign. 2723.8680 minus 2279.6230 gives me the length of the canyon. So 2723.8680 minus 2279.6230 gives me 444.245. 444.245. Wow, that was a tough problem. Well, let's see what the question asks again. Determine the width of the canyon to the nearest foot. Well, we determined the width of the canyon was the length ED. And so to the nearest foot, I'm going to round it to the nearest whole number. So I would come down here and I would say in a sentence, the width of the canyon is 444 feet. And then I'm done.